tutorial on operations management. We are going to look at how workforce scheduling is done in a service or manufacturing organization. Suppose that we are interested in developing a workforce schedule for a company that operates 7 days a week and provides each employee with 2 consecutive days off. The objective is to identify the 2 consecutive days off for each employee that will minimize the total slack capacity, thereby maximizing utilization of workforce. Slack is basically difference between employee available and requirement of employee. The work schedule for each employee, then, is the 5 days that remain after the 2 days off have been determined. Let us now try to allocate work for the following employee requirement for a company for the week. On Monday, employee needed are 8, on Tuesday, 9 employees are required, on Wednesday, 2, on Thursday, 12, on Friday, 7, on Saturday, 4 and on Sunday, 2 employees are required. In order to proceed for preparing workforce schedule, following steps are followed. Step 1. From the schedule of net requirements for the week, find all the pairs of consecutive days that exclude the maximum daily requirements. Select unique pairs that has the lowest total requirements for the 2 days. In some unusual situations, all pairs may contain a day with the maximum requirements. If so, select the pair with the lowest total requirements. Step 2. If tie occurs between the lowest total requirements for 2 consecutive days, choose one of the tie arbitrarily, if no constraints are there. Step 3. Assign the days as off for the selected employee. Subtract the requirements satisfied by the employee from the net requirements for each day the employee is on work. Step 4. Repeat step 1 through 3, until all the requirements have been satisfied or a certain number of employees have been scheduled. Let us now try to schedule the work for the given problem. Find the lowest requirement for 2 consecutive days. For Monday and Tuesday, total requirement is 8 plus 9, that is 17. For Tuesday and Wednesday, it is 11. For Wednesday and Thursday, it is 14. Similarly, we conduct the total for 2 consecutive days, for the whole week, as shown here. We observe that Saturday and Sunday are the 2 consecutive days with lowest total requirements, that is, 6 workers. Thus, we assign employee 1 as off on Saturday and Sunday. Now, we calculate the new requirement of employees, since employee 1 will be working on the other days of the week. Thus, we need 7 workers on Monday, 8 on Tuesday, 1 on Wednesday, 11 on Thursday, 6 on Friday. The requirement for Saturday and Sunday remains as original requirement of 4 and 2 days respectively. We repeat the iteration again, with the new total requirements of workers on each day. As shown in here, we observe that Saturday and Sunday have the lowest total requirement of workers. Hence, we assign the employee 2 as off day on Saturday and Sunday. Since employee 2 will be working on other days of the week, we calculate the total requirement again. We get 6 workers are needed in Monday and so on. The calculation is shown here clearly. We repeat the iteration again, with the new total requirements of workers on each day. As shown in here, we observe that Saturday and Sunday have the lowest total requirement of workers. Hence, we assign the employee 3 as off day on Saturday and Sunday. Since employee 3 will be working on other days of the week, we calculate the total requirement again. We get 5 workers are needed in Monday, 6 workers on Tuesday, 0 workers on Wednesday, and so on. The calculation is shown here clearly. The same iteration is repeated and allocation is done for employee 4. Employee 4 is also given off on Saturday and Sunday. The new requirements is calculated after subtracting the allocation from the total requirement. The same iteration is repeated. Here, we notice that total requirement for Tuesday and Wednesday is the lowest, that is, 5 workers. Hence, employee 5 is give off on Tuesday and Wednesday. Again, the new requirements is calculated after subtracting the allocation from the total requirement. We get, 3 workers are needed on Monday, 5 on Tuesday, 0 on Wednesday, and so on. Again, we perform the same iteration is repeated. We notice that total workforce requirement on Saturday and Sunday is 4. The total workforce requirement for Sunday and Monday is also 4. In case of a tie of total requirements, the tie can be broken arbitrarily, if no constraints are given. Hence, employee 6 is given off on Saturday and Sunday. You may choose to give him off on Sunday and Monday. Again, the new requirement of workforce is calculated, as employee 6 will be working on other days. The new requirements are 2 workers on Monday, 4 on Tuesday, 0 on Wednesday, and so on. We continue the iterations, till we have allocated work to 12 employees. The maximum requirement is 12 employees as given in the problem. That is the requirement on Thursday. The total work schedule is shown here, for the 7 days of the week and for 12 employees. Now, we find out capacity on a particular day of the week. This is obtained by finding out how many employees had day off on a particular day of the week. For example, on Monday, employee 7, 10, 11 and 12 have off day. Thus, out of 12 employees, 4 had day off, that is 8 were available for work. Similarly, on Tuesday, only employee 5 has day off. Thus, 11 employees are available for work. Similarly, we calculate the workers available on each day, and that denotes the capacity available. Slack is obtained by subtracting capacity available from the net requirements on each day. On Monday, the total requirement was 8 workers, as given in the problem. And we found out that 8 workers are available. Thus, slack is 0. On Tuesday, 11 workers were available, but the total requirement was only 9 workers. Hence the slack is 2 workers. Similarly, we can calculate slack for each day, as shown in the table. Finally, we can calculate how efficiency of the workforce schedule. We create a table like this. We find out the total requirement of workers for the week, as given in the problem. It comes to 44. We then calculate the workforce available, depending on our workforce schedule design. We find the total for the week as 60. Efficiency is capacity used multiplied by 100, and divided by capacity available. In this case it is 44 multiplied by 100, and divided by 60. That is, 73.33%. The 100% efficiency is expected, however, it is difficult to design schedule with 100% efficiency. A higher efficiency is desirable. Thank you.